So we want to move from our understanding of the formula for the volume of pyramids to find out what the volume of a cone is. So I have a diagram right here, and that shows a progression from pyramids with less sides on their base up to pyramids with a lot of sides on their base. So this first one, I have a square pyramid. So that means the base is a square, four sides, and then it goes up to a single vertex up the pyramid. And then here I have a hexagonal pyramid. The base is a hexagon, like we saw in that last problem, going up to a vertex. Here I have a decagon. That's a 10-sided shape. So we have the decagon base going up to a vertex. That's a decagonal pyramid. Here I have a 100-sided polygon. So it looks like a circle, but actually all these little points, these little red points, are vertices in that polygon, and the little lines connecting them are sides of that polygon. And so this right here is actually a pyramid with a base that has 100 sides. So I think you might notice that the more sides the base has, the more and more it looks like a cone. As we go to the cone right here, remember a cone being a circle base going up to a vertex. So this here is the actual cone where we're using a circle on a base. There's no sides here, it's an exact circle. This looks very similar to our 100-sided polygon. So it turns out that cones actually follow the same pattern as pyramids, where a cone is 1/3 the volume of a cylinder with the same base and the same height. So we would, for a cylinder, the formula would be the area of that base, which is, we'll get to in a second, the area of a circle times the height. So let's first ask, what is the area of the base of a cone, which is a circle? Well, that's pi r squared. Remember, the area of a circle is pi r squared. So now all we need to do is put that into the full formula. So knowing that we're going to take 1/3 the volume of a cylinder, we want to do 1/3 times pi r squared times h, because pi r squared h is the volume of the cylinder, and we want 1/3 of it. So very similar to the pyramids, and we can use that now to find the volume of the cones we have in the next several problems.